and welcome back to another professional prep video. So this is the first video in a segment of how to solve differential equations using separation of variables video. So I've decided to split up this series of how to solve differential equations into a couple different videos so that we don't get overwhelmed. Now this does not mean that solving them is particularly difficult. I think with a good amount of practice, you can really master this method, but I wanted to split this up so that we don't get confused and we don't try to go for too much at one place. So in this video, I'm going to cover the actual separation of variables step. So we're going to use a method called separation of variables to solve these differential equations. And they consist of many steps, including the separation of variables step, antiderivative step, and then some algebra usually. So I'm going to break this down. This video is going to cover the separation of variables step. Then the next video, I will likely add the antiderivative step. And maybe we can just finish it out in a third video, or maybe if I feel that we can do it, I will just finish it out in the next video. But you already know how to take antiderivatives, so the really new step here is going to be what I'm showing you in this video, the separation of variables step. So I have 3 examples laid out for us. So think about in a traditional algebra class, the whole point of separation of variables is exactly what it sounds like. You're trying to get the x and the y's in this case. Or it could be the t and the r's, the s's and the w's, anything, if this were ds over dw or anything like that. In this case, I've chosen x and y's. We're looking to get the y's and the x's on opposite sides. So here's how we're going to do it. Let's take this first example. And this is very similar to something that you've seen in an algebra class. So it's not actually too complicated at all. I just want to go over it because it's a very important step. So I'm going to start by multiplying I shouldn't say multiplying. I'm going to start by bringing the dx over to this side. So the thing is that the operation is technically not multiplication here. However, you can think about it as multiplication if you would like, because in effect it behaves the same way. And then I'm going to bring the 5y squared over to the dy side, and then that will separate our variables, right? Usually you don't have to write out multiple steps for this, so not particularly difficult to just bring over the 5y squared. And obviously that's going to be divided by, because here we're dividing by 5y squared. And we're going to quote-unquote multiply. Notice that this is not actually multiplying and dividing. It's a different operation altogether, but it behaves the same way. So just to make everyone understand, I'm going to use those terms. So we're dividing by 5y squared and multiplying by dx. And boom. We have now separated our variables. Y is on one side, x is on the other. And yes, this is literally it for the separation of variables step. Next, we would find antiderivatives and go from there. But this is, in effect, the most important step. And this is the actual separation of variables step. So let's try this example now. Now remember that this is not actually multiplication and division, but we can call it that for our purposes. So this one's a little bit more loaded, but we'll be fine, right? So we have to bring the y over here and the dx over here, which actually ends up being rather simple. dy over y, because we quote-unquote divided by y, is equal to 2x squared dx, because we multiplied by dx. And boom, now our y's and our x's are on opposite sides, and there's the separation of variables step. Now here's the last example, and this is going to be a very simple example. The dy is going to be on this side by itself. The dx moves over, 12x dx. And that's going to be our final answer there. Another thing you could have done is you could have moved the 12 over to this side and had dy over 12 equals x dx, but I would recommend leaving the coefficient on the right side with the x's in this case, just because it makes it easier, or at least it might make it easier later on. So, but that's completely up to you. It's not incorrect if you move the 12 over. And yeah, that's all I have for you for this video. This is called separation of variables, and in our next video we will discuss how to finish solving these. But for now, if you have any questions on this step, then please feel free to email or leave a comment. And if not, just get some practice. This is a very important step, believe it or not. So yeah, that's all I have for you for this video. Have a great day, everyone.